For our main topics today, I want to talk about experiments. There are really great chapters and or textbooks that talk about how to design experiments or studies with humans in a controlled setting or true experiments. And I link them all here or point you to them here and the relevant chapters. The lecture today and next time is based on a compilation of these kind of things, but as always, please look at the original sources for a lot more coverage. Okay, so let me start with this idea of causal relationships, because experiments are designed to establish causal relationships between variables. That's what they do best. Let me start with this idea of causal relationships and a discussion of what it means, or what does cause and what does effect mean in this context. So here's a mouthful. When we talk about a cause, we talk about an insufficient but non-redundant part of an unnecessary but sufficient condition. And I'll say this 3 times very quickly. I'm kidding. I should stop making jokes. This is really not, I'm not on my best game, it seems. Tough audience. Okay, so let's break this down a bit and see what this means. Let's think of the example of using a match to start a forest fire. Okay, so forest fires can start for a variety of reasons. They can start without matches just as well. For example, if lightning strikes, like we saw on the cover page or what have you, or from a lit cigarette or whatever else, right? Electrical short circuit. So fires can start for all kinds of reasons. Therefore, a match is not a necessary condition to start the fire. That makes sense? At the same time, matches don't always start fires. For example, if it's raining, it's very unlikely that your match will succeed in starting a fire because of the humidity. So it's also not a sufficient condition for a forest fire. Does that make sense? Okay. So you need lots of other things for that to work. So we're saying that a match is part of this bigger constellation of conditions without which a fire would not result. So it's insufficient because, it also needs oxygen and dry leaves and the right whatever, a bunch of things that need to happen as well. And it's non-redundant because it needs to add something unique besides these other things. For example, if, there's already a lightning strike or something like that, that by itself can start a fire in the right conditions, adding the match would do nothing in addition to that. Okay? So it's insufficient, but non-redundant part of an unnecessary but otherwise sufficient condition. That's the technical term. That's the cause. Okay, that makes sense? So now the effect is, to reason about the effect, we have to reason about a counterfactual. The counterfactual is what would have happened to those subjects or what have you, had the cause not been present, but everything else stayed the same. Okay. So if you're doing a medical treatment style study, you're comparing what actually happened when people received the treatment to what would have happened to the very same people if they simultaneously at the very same time had not received the treatment. That's the counterfactual. That makes sense, Elizabeth?
I have a question about the categorization of the cause again.
Yes.
So there should be like some type of difference between the presence of oxygen, dry leaves, like all of these conditions that have to be true, and then adding the match for the lightning is like, it is the cause, right? Because it's building on a foundation of all of these things that have to be true.
That's right. And
So
then
is there a different, are the other conditions also in Inus conditions, or are they like a different category of conditions?
A match with the right constellation of conditions and without a lightning strike could be a cause of a forest fire. The match with the same constellation of conditions, but also a lightning strike, may not be a cause of the forest fire. Could be that the lightning.
Are they classified differently, like the fire starting thing versus the conditions?
Oh, so you're saying could the oxygen also be a cause of the forest fire?
Yeah, because like oxygen doesn't cause fire, but it like there's like I feel like there has to be some other categorization there, right?
Can I try, because I have a similar question, and I wonder if it's the same thing you're getting at. Is an Inus condition with respect to other conditions?
I assume.
So, and it also has to, so by itself is not sufficient.
Right.
But with respect to the other conditions, all of a sudden becomes sufficient.
Mhm.
Okay, so in this case, if oxygen is part of your assumptions, oxygen is not an Inus condition, this is redundant.
Mhm.
But if you take away oxygen, then all of a sudden, a match does not become an Inus condition because now it's not sufficient.
Mhm.
Okay.
So is the Inus condition the thing that would that like has to be added to something to cause a fire in the first place, but then there are like normal conditions that it is dependent on, and those would be like the oxygen and dry leaves? Or are they all categorized the same way?
You're essentially asking, could oxygen and dry leaves also be an Inus condition?
Yeah, but like, I mean, if you walk into a forest, it's not just gonna just spontaneously combust, but it could have all of the conditions that given an agent. But like the agent is necessary, right? I don't know.
Yeah. Yeah, I don't know. I need to think more about this. I take your question, but I don't know. If I can reason in the same way about oxygen, it seems like you can, but then this whole thing becomes less intuitive. If everything then becomes a cause. Let me think about this some more. Maybe we chat next time. Yeah, sorry. Okay. So let's talk about the effect now. This is pretty important. Okay, there was something subtle here. We're comparing what happened to some people that received some treatment at some time to what would have happened to literally those very same people if they had not received that very same treatment at the very same time. And the effect is the distance between these two. Okay. Notice anything strange here about the counterfactual?
You can't really know what would have happened. Like if it didn't actually happen.
The counterfactual is unobservable. Okay. We cannot know because unless there's some parallel universe in which these things are identical except for the treatment, right? And time is synchronized and whatnot, right? We have copies of ourselves which brings me to this great show. Has anybody watched this? The Man in the High Castle? Really? It's a great show. It talks about what would have happened if the Nazis had won the war instead of lost it to the US. It's a great show. Hence the analogy. But okay, so counterfactual, not observable, long.
I'm not quite sure about why they simultaneous, why you have to have at least two people? Why couldn't it be what happened to a person, a single person, had that person, had he or she had not received that treatment?
Yes, so for every subject, you would have to do that subject's counterfactual, and then you aggregate over all the subjects in your study or something,
Oh, okay.
right? Okay. So you have to copy everything. Everything has to be exactly the same. So all the same people, you know, maybe each received the treatment at different times in reality. So they also each have to have not received the same treatment at those same times, and so on. Everything has to be exactly the same except the treatment. Right? Okay, this stretch. Cool. So this is pretty important. You can't actually ever observe the counterfactual. Okay, so that's kind of a bummer, right? So what happens is you have to approximate it. You have to infer it as best you can. And literally all of science, right? Because we can actually, this actual counterfactual, the real one, there is no real one, cannot be observed, does not exist. Okay, so then all of the experimental design and all of causal inference and all of everything really is trying to create a as high quality as possible source of counterfactual inference. Okay. And it's good to have a good understanding of how that may differ. Sorry, so you do that in order to understand how that differs from the treatment condition. And it's good to have an understanding of how that is limited, all the ways in which it is imperfect, so that we can reason about the strength of our claims. Okay, this is really a key thing. If you have bandwidth before spring break for only one item, you're thinking about the beach in Mexico and whatever else. But you have bandwidth for one item. This is a great one to remember. There are, I claim, exactly 3 ingredients when you're trying to when you're trying to establish a causal relationship between 2 variables. Okay? Number 1 is that the cause comes before the effect is observed, because of how time works in our current universe. Okay, no, I'm serious. Number 2, that there has to be some correlation between the cause and the effect that is measurable, right? Changes in the cause must be correlated with changes in the effect. Okay, it's not sufficient for this thing to have a causal relationship. You can have spurious correlations for all kinds of reasons, but it is absolutely necessary. Okay, if you change the cause and the effect stays exactly the same, the cause could not have been, therefore the cause of that effect. Okay, and number 3, you have to be able to exclude plausible alternative explanations for that same effect. Okay, so you can sort of see how the first 2 are, easy. I mean, the first one is sort of easy because you can set this up, or you can infer it from observational data, or what have you. Sort of, timestamp data is often available, or if you're running an actual experiment, certainly, you first treat the people and then later you observe what happened to their health or what have you. They're certainly easy. Second one is also easy because you just measure the things, right? Third one, super hard. Right? Because then how do you know if you've excluded all the right alternative explanations. Kaya.
Yeah, and I guess like, everything that we know has come through observation, so isn't it kind of true that we can never, like, the third step is always ongoing? Or like,
Seems like it's
we can't
impossible.
establish a true causal relationship?
Well, yes, but also because there is no observable counterfactual.
Yeah.
So it's sort of this never-ending quest, but at some point, you're confident enough that you've tried your best and you've excluded the plausible ones.
Mhm.
And then you just call it a day, right? And, you know, the course of science is such that others will try to replicate your results and maybe confirm them or maybe refute them and so on. And so over the course of science, then we gradually build more and more confidence about some particular relationship.
We learned about gravitational waves.
Right, and then at some point, everything changes and, you know, it turns out everything we had believed was wrong. So but that's just how it works. There's nothing I can do to change that.
Mhm.
Yeah, it's still fun though, I think. I enjoy it.
But at the third point, it's impossible. Because it's impossible to prove something that doesn't exist.
Technically, yes, but in practice, you do your best. Okay, so we're going to talk about ways to get closer to your best, to achieve your best. Well, be best was this your turn. There's no place for politics. Okay, so here is sort of a diagram showing the same thing. You have to kill all of these alternative explanations. So now, here's an argument that often you may have with reviewers. I often get this. You know, let's say we have some study that's making strong claims, and we don't have a true experiment with randomization and whatnot, so we can be super sure. We're going to talk about why that's a good design in a minute. We're making some strong claims, and then the reviewers come and say, well, you know, this is not good enough, because what if there are confounding variables that could explain the same effect you're claiming here? And then they stop, reject, and then they don't stop, reject, you know, there could be confounding variables. So then as an author, I get really frustrated and angry when I see this, because I claim this is not a good enough argument. Okay? A good enough argument would be one that articulates plausible alternative explanations that I had not considered, and articulates the mechanism, states the theory, right? Articulates the mechanism. If you just say, well, but like, what if it's, you know, the weather that is causing, you know, something. And I say, well, that's not good enough. You can't just claim that. You have to explain a plausible mechanism through which the weather could cause something. And then I, you know, argue whether I address that or not with my study design. But if you just say, oh, the weather could have explained your results, reject. That's not a good enough argument. Right? Because it's not plausible. You have to explain why it's plausible also. Come on.
You're saying the Cartesian skeptic paper review is not a valid one.
I don't know what that means.
It's like an annoying philosophical like argument where where the quote like I think therefore I am comes from, or like that's like the only thing that's like the only thing like Rene Descartes could like claim that he actually knew.
Okay.
Because otherwise you would just say like, oh, like what if a demon was like tricking you into seeing this?
I see. Okay. Yeah. So I would probably argue that that's not a valid argument.
Yeah.
Valid argument.
Definitely not an interesting.
Also, you know, advice for you when you're reviewers. I think it's not enough to claim that they have not considered some variable in their analysis, unless you also have an explanation for how that variable could be a plausible cause of the same effect. Make sense? Okay. Okay, so now we're going to talk about experiments because, as it turns out, experiments do this really well. Okay, let's talk about experiments. So experiments where, sort of in the medical treatment sense, you have some treatment and you randomly assign the treatment to half of your study subjects, and maybe you give a placebo to the other half or something like that, and then you compare changes in outcomes between the two groups. Very standard medical trial setup. Okay. Why is that a good source, in fact, the best source we have for establishing causal relationships between the treatment and the health outcome, say? Well, for one, obviously, the first one is satisfied automatically because, you give people the treatment and then later observe what's changed in their health. The second one is somewhat trivial if you have ways of measuring these outcomes. Like you just see how many people died, or count how many, right, or whatever. See how quickly their health improved, or whatever else. Like if you have some measures of outcomes, certainly you can compute those, and you can compute correlations between the treatment and those outcomes and whatnot. You can compare them between the groups. Okay, so very easy. Third one is the magic, as always. And third one is the magic because of the magic of random assignment. Okay, this is $1 billion idea for today. Okay. Because if you have enough people in the two groups and you randomly assign them, on average, the two groups will be indistinguishable in terms of whatever characteristics could have also caused those effects. So let's say tall people respond much better to the treatment, but you randomly assign the people to treatment and placebo. So on average, there'll be just as many tall people in both groups. Sense? So, whatever other, in fact, this is great, right? So randomization magic in experiments is so good that you don't even need to articulate these plausible alternative explanations. You simply don't care, right? You don't even have to know what they are, because you can expect that on average, they are the same between the two groups. Right, so if there's still a change, a difference in health outcomes in the treatment group compared to the control group, it must have been because of the treatment. Because all the other things that could have also caused those health outcomes should be on average indistinguishable between the two. Isn't that a really great idea? You see this? See some skepticism.
What happens if, on average, it's more effective in tall people, but it's less effective in some other groups that are equally represented? Wouldn't it like average it out? And possibly not effective.
So what you're saying, what happens if there's no effect?
Yeah.
If there's no effect. I don't quite follow. So there's as many tall people in both groups, and there are as many
I guess maybe
short people.
another way is like, what if you're trying to see if it heals people for this thing? And in some people it made it worse, and in some people it healed them. But it might have been something within the demographics of people with this
except the demographics of people are indistinguishable between the two groups.
Yes, but that way we lost that information. So for example, if our group, of say 50 plus, regarding age, and that medication or whatever works for them, but we are mixing them with the rest of the sample. So on the study, we'll not see effect because most of the population will not respond for that. So we will be missing that information.
So I don't agree with that, but I do agree with Elizabeth's point. I don't agree with yours, Luis, because you're saying the treatment is effective for the 50 plusers, right? So they should get an improvement in health, right? And it's not effective for the 20 minuses. So nothing happens here, right? The control gets a placebo, so nothing happens in both cases. So overall, there'll be better outcomes in treatment because of the better outcomes among the 50 plusers, even if there's no effect on the 20 minuses. This is why I don't agree with your example. I do agree with Elizabeth, though, I think, which is that whatever improvement the 50 plusers have is exactly negated in the 20 minuses, has exactly the opposite effect.
Yeah, so we will balance out and you'll miss the 50 plus.
Right. So then I sort of, when I aggregate them all together, I see no effect here. And I had no effect in the control, and I conclude that there was no effect. So this is, I agree with this. This is great, which is why we're going to talk in a minute about better designs for setting this up than just random assignment to two groups. I agree with that. Right. So if there's no effect here, this could be a risk. We have a better design to deal with that. If there is an effect, what I'm saying is, if there is an effect, you can be very confident that it is because of the treatment. Because other things are the same between the two groups. Okay? So sometimes that's not the case when the samples are small. You can have too much variance between the samples, the groups. That may be the case. But if they're large enough, whatever other thing could have explained this should have been the same between them. Okay. Okay. All right. Quick aside, technical terms. We're going to talk about mediators and moderators. It's important to remember what these terms mean. So let's say we have some independent variable x, and we're testing the causal relationship between that x and a dependent variable y. A mediator is another link, another path in this explanatory chain. We call that a mediator. For example, let's say we are testing whether socioeconomic status explains the child's reading ability, causes the child's reading ability. Okay. Very likely to be the case, right? Richer, I don't know, families have more money to buy more books. And the kids end up reading better because they will have been exposed to more books growing up or something. Okay. But at the same time, the level of education of the parents could act as a mediator in this causal link, causal relationship, right? Because it can both explain the outcome and be explained by the cause. Okay, so higher socioeconomic status makes it more likely that the parents had higher degrees, right? They went to college and whatnot, higher education. And in turn, the parents' level of education, regardless of how they obtained it, makes it more likely that they read books at home. Okay. So you can see that there's this other path through which you can arrive at the effects.
You said that socioeconomic status cause the parental education level.
Hmm.
I don't necessarily disagree with that, but it seems a little funny because if you're to measure it at a slice of time, then socioeconomic status would come after the parental education level.
Presumably there's some generational wealth assumption and whatnot.
Okay, so that doesn't.
It's like, this is an oversimplification, obviously.
Oh.
But, the parents, when they were growing up, were also wealthier, usually, right? The kids of wealthier parents end up being wealthier themselves on average, right? So then, the parents would have sent them to college and whatnot, right? So it could also be what led to this higher level of education in the parents. But this is by no means the only mediator here. There could be others, right? Not the only factor. But I'm showing you a way through which some of the variance in the child's reading ability that you wanted to attribute to socioeconomic status may also have to do with the level of education of the parents, which mediates this relationship. That's a mediator. A moderator is the following. So you have, here's an example. You have, say, a causal link between work experience and salary, right? More senior, excuse me, more senior people earn more money, typically, right? They pay more. But at the same time, gender may moderate this relationship. Meaning, depending on the values of this variable, the effect of work experience on salary may be different. So say, assuming only binary here, for men, their salary may grow faster with experience than for women. Be one way to instantiate this. Does that make sense? So gender here is a moderator of this causal relationship because it changes the strength of the effect of this variable onto the other. Come on, yeah.
So just to rephrase for myself, mediators are just like intermediate products.
Yes.
And moderators are like they're just like functions on the causal relationship that like change its character in some way.
Yes.
Yeah. Okay.
What's the difference between moderator and cause? Why the gender cannot be the one of them?
Because gender by itself does not determine salary. It's not how your employer decides how much to pay you. It's not a direct function of gender. It's in some ways implicitly a function of gender through this moderator mechanism. We know that, I don't know, in the US, for every dollar men make, women make however many cents on average, less than $1. Okay, so it is sort of implicitly affecting that, but through this moderating mechanism. People don't ask you, what is your gender, and they assign a salary, right, based on that. They look at other things like, what the role is that they're hiring for and how much experience you have, et cetera, et cetera. Right? They look at things that have to do with the actual job when they decide how much to pay you, right? They don't look at your demographics usually. It's also illegal.
Yeah, I know that, but it's not very clear to me, like, what's a fundamental difference between them. Can you give another example? Another example of moderator?
For work experience and salary, or
Yeah, it could be, or another.
here, the complement, that's what I was thinking about, is our moderators, like all the variables that contribute to our time, like our y
Yeah,
variable.
that's the same.
No. The moderators are those variables that change the strength of this relationship, depending on the value of the moderator variable. So I'll give you one example. Let's say salary is some linear function of work experience is 147 times experience measured in years, and this is measured in dollars or something. Okay, plus some epsilon. Okay, that's how they decide your salary.
Yeah.
Okay, so now to incorporate gender into this, okay, you say something like salary is, something times experience plus something times gender plus something times the product. Okay. So, in other words, you could say something like,
Yeah.
okay. So depending on the value of this variable, the relationship between experience and salary changes.
But it can be in an opposite way, right? You can put the gender outside the certificate and put the experience inside.
Sure.
And in that case, will you call gender as a cause, but the experience as a moderator?
Okay, yeah, maybe, but remember, you gotta have a theory. Like all of this starts from theory. You don't just try everything until something sticks. Right? You have a theory that explains the mechanism and so on, that you start all of this research from. Right, and here it's arguably more plausible of a theory that experience is the main variable and gender is the moderator rather than the other way around.
It also depends on research question, right? If the research question is how work experience impacts salary, then of course you want to compare salary against experience, and gender will be a moderator variable. Right. Depends on the question.
I saw another hand earlier. No. Okay.
Does it mean still like both factors contributing to the output variable, but like here, but according to the theory or based on what research question you want to ask, we focus on there's one primary factor we're focusing on. Here it's a work experience.
Right. Yes. So always start from theory, and in this case, the stronger theory arguably is the one about experience versus salary. Experience as a main cause of salary rather than gender as a main cause of salary.
Yeah.
Certainly gender as a moderator. Right. Okay, correlation is not enough. We know this. Lots of examples here. This is fun. I'll show them again. I showed this in my talk the other day. Films Nicolas Cage appeared in, and people drowning in a pool. Very high correlation. There's another one. The revenue generated by arcades versus computer science PhD degrees in the US. Very high correlation, and so on. There's a website that shows these kinds of plots, all with real data. So it's it's fun if you want to waste some time on the internet. Okay. Experiments. Okay, let's talk about some of the details here. terms, definitions, we call experiment a study in which some intervention is deliberately introduced to observe its effects. So researchers manipulated something in order to observe its effects. We call this generally an experiment. Randomized experiment or true experiment is the one where these treatments are, the subjects are assigned to receive the treatment or an alternative condition randomly. And most often, I think you will see the two terms being used interchangeably. So like when people talk about experiments, they usually mean true experiments, which means experiments with randomized assignment of subjects to conditions. That's sort of the intended meaning of the term. By the way, this is very different and it's very annoying from the use of the term experiment in, say, the systems or the ML community, where people call, comparing something against a benchmark, they always call that experiments in their papers. That is absolutely annoying, because it is absolutely not that. Okay, it's not an experiment. Okay, a quasi-experiment is, so quasi means kind of like experiment, almost experiment, is an experiment in which these subjects are not assigned to conditions randomly. Okay, we call that a quasi-experiment. So it's not quite an experiment. There's no random assignment. Otherwise, there's still some difference in conditions and whatnot. A natural experiment is, we use this term when we talk about causes that have occurred naturally, that aren't manipulated by the researchers. For example, the pandemic is a great example of a natural experiment. It's not, I guess, depending on which conspiracy theories you subscribe to, it's not that somebody introduced the pandemic and manipulated the whole system, but it's sort of a naturally occurring phenomenon, and you can observe its effects. Or think of inflation, or think of whatever else, something that's naturally occurring that researchers don't manipulate directly. Earthquakes is the example here. And then correlational studies are, or observational studies, it's basically study that simply observes these change in direction of a relationship among variables without having manipulated any of them directly. Okay. So we talked about how these are the gold standard for science and that they're great, arguably, because the randomization ensures this item number 3 in our list of ingredients for causal relationships. Very often, it's just impractical, if not impossible, to do true experiments for lots of interesting questions. So people resort to doing observational studies or correlational studies, including myself. And the trick is always to try to design these in such a way that gets you as close as you can to the sort of true experiment. And you'll never get there. It's just not possible, right? You will never have the level of confidence that you get from a true experiment by doing correlational observational studies. But the trick is to try to get as close as possible to that. That's where the magic is. Okay, pandemic, yeah, that was a good example. Talked about experiments, the control versus the out of control group, whether you're doing experiments or not. Okay, let's talk about some designs now. Most basic design is the one I talked about earlier. So here, I'm using this diagram to summarize the design. There are 2 conditions on rows. There's random assignment of subjects to the different conditions. There's some treatment or intervention in one condition and a nothing in the other one, in this case. Okay, so the X denotes the intervention. And I measure some outcomes, O, I assess them somehow after the treatment or the intervention. Okay, this is the design which we talked about earlier. So one limitation of this is that you cannot separate the active ingredients in the treatment from the mere act of having treated in the first place. Okay. So remember here you gave an injection with the vaccine and the treatment group, and you gave nothing to the control group. So maybe their changes in outcomes are not because of the actual ingredients in the vaccine, but rather because they got a shot in their arm or something. And that's really what caused it. And you can never know from this design. That makes sense? See the point? I see Luis is skeptical.
Yeah, you can do the same, like injecting placebo.
That's exactly right. So you do the same. You give treatment versus placebo to try to isolate the active ingredients from the act of being treated in the first place. So that's one. Or you could do both. You could have a placebo and no intervention at all in an actual baseline control group. Okay, so you can have three groups you're comparing against.
So in this case, gold standard, the XB is a placebo.
Presumably.
Because I feel like this second experiment is talking about like trying to compare two treatments. But the first, can we take because the first one there's no treatment. Right? The
Yes.
first one is in the other control group there is no treatment. But generally from the experience I have been like this, the control group is the one with the placebo.
Right.
So
Right. So I'm representing that here as saying treatment group with active ingredients versus control group with placebo, but still maybe an injection.
I see, but in this case, we talk about the limitation of the second one. If no effect cannot distinguish both are equally effective or equally ineffective.
Yes.
The only possibility is equally ineffective because XP is the placebo.
Yes. So here, this text assumes that we're using the diagram to represent comparing two different treatments, A versus B. You want to see maybe which one is more effective. You have two formulations, the Pfizer versus the Moderna vaccine or something like that. Okay, you want to see which one is more effective. So you could do that. But if you have two treatments, then you need an actual control group with a placebo here to do what we just discussed. Okay, note how in none of these we tested the subjects, we measured anything about them before the intervention, before the treatment. So this may be a problem, especially if people drop out during the study. Okay, so knowing something about them before administering the treatment is useful, but not always. For example, it could also be undesirable if testing them before the intervention makes them too sensitive to the intervention you're about to administer, which will change the way they react to it, just because they're not primed to know what was going to happen or something like that. So it's not always a good idea to do this. It's also not always possible to do this. Okay, so but if you do want to do this, you can presumably test them before you administer the treatment and test them after. That's a good thing. You can have multiple treatments, you still test them, that's all fine. You can have a factorial design where you have two treatments A and B, and you administer them in different order. Or I guess you have two treatments with two versions each, right? So you administer, the first version of the treatment, followed by the first treatment A, followed by the first version of treatment B, and so on. So have all of this combinations of values of these.
Could also change the order. So X, A1, A1.
Yeah, great. Yeah, we're going to talk about order effects more in a minute. So that's also important. You can have, so I'll come back to this. Give me a minute. You can have longitudinal observations followed by some treatment, followed by more longitudinal observations. Or you can have crossover effects where you administer treatments at different times with observations interspersed. Okay, so that's one way. Now, let's see. So another way to think about the design of these. Oops. If you have one independent variable or more, depending on that, you have a basic design versus a factorial design. And then depending on how many conditions you have to decide between a between groups design and a within group design. I'll tell you more about what this means. So between group design, here's an example, or between subject design. Every participant is only exposed to one experimental condition. Okay. So if the task is, say, to type a 500-word document, and I'm trying to test the design of two different keyboards, or rather 3 different keyboards, the one we all use and a couple of alternative ones. Every participant types one document using only one of the keyboards. Okay. So I have different groups of participants typing documents with the different keyboards. Okay. A within group design would ask the same participants to type the document using the different keyboards, or type different documents using the different keyboards. Okay, within group or within subject design, because it's within one group, the same subjects are tested multiple ways. Okay. Can you think of some advantages and disadvantages of both of these designs between groups, between subjects versus within group, within subjects? Some ideas.
About the disadvantage of using group, I think probably because you have to do the same task using different method in certain order.
Yeah.
And the order may affect the performance.
Yes. That's always the big issue. Right?
But the randomized is shouldn't even out.
Great. So we have to do something clever to counteract that problem. Yes. Right.
Within subjects is nice because you don't have to worry about things that are unique to them, kind of skewing the analysis, like the brain or
Yeah. Like, what if individual characteristics have a huge influence on the outcome? If it's within subjects, those don't matter anymore at all or as much, because it's the same person in doing both tasks. So,
I was thinking about one task and like within objects, if one task can influence the second. So for example, on the keyboard, if you are using one keyboard first, then you, I don't know, you are already from with some ideas from the first keyboard.
or within subjects.
Yes.
Absolutely, yes. You're maybe learning how to be better at the task, and you're transferring some of that learning to a subsequent task using a different keyboard. So it's not because of the keyboard was better, but it's because you've gone better at the task through your previous experience that you're doing better.
Yeah.
Yep, exactly.
I think another thing we talked about in this class is sometimes you can infer, like, let's say you're comparing your tool against another tool, and the subjects can infer which is yours.
Mhm.
They might have this bias to say yours is good. They recognize the standard tool, but they don't recognize the other one. They might be like, oh, you're testing that one.
And that would not happen with the between subjects design?
Well, if you're only presented with one,
I see,
then you might not realize.
I see. Yeah, I can see that. Yep. Howard, did you have something? I saw another hand somewhere here earlier. Yeah, yeah.
Are within subjects, if we are trying something new versus something that exists, maybe participants are more interested in experimenting the new thing. And if they get the control version, they will not learn anything actually, or get anything new, so they might not be as happy in the end of the experiment. So now from more of a recruiting side, if we are giving them something to do, for example, that is nothing new versus something new, they will probably prefer something new and feel like
I
they
see.
accomplish more.
Mhm.
I don't know if I'm explaining it very well.
So presumably you randomly assign them and they have no choice.
Yes, but then the people that manage to do something new might be more more interested in the results at the end than the other ones.
Yes, there's something, so novelty effects in general are well known and they impact the results of experiments. Yes, I agree with this. Any more? Here's a list I had. Order effects is one type of thing to consider. People learning from the earlier conditions and transferring that learning to the later parts of the experiment, or fatigue, which could work in the opposite direction. If I have a within subjects design, that means I have to give the same people more tasks or multiple conditions, right? So the experiment takes longer. So they get tired maybe towards the end, and they do worse at the tasks on the conditions in the later part of the experiment because they got tired, perhaps, and not because the intervention was worse. Okay? So this could work both ways. You can have learning, you can have fatigue, or you can have both. One, right, which is why between subjects may be preferable here, that there is no learning effects. Everybody does one condition only. And the whole thing takes longer to complete, right? Because everybody does one condition only. But shorter. Between subjects would be a shorter experiment because every subject is tested only in one condition. Within subjects would make the experiment longer for participants because every subject would be tested in multiple conditions. So if you're a study subject, it would just take longer, right? So you get tired, maybe even bored. What's a big disadvantage though? Good. Direct consequence of this fact that you
Maybe more
need
participants.
that's it. But you need more participants. With a within subjects design, I get more data out of the same participants, right? Because I test every participant on all the conditions. With a between subject design, I need, n times as many participants to get the same amount of data. That makes sense? And it's hard to recruit people, it may be expensive to recruit people for studies. So this is one big disadvantage of between subject designs. You need more participants. Do you see why?
I see why. Just being very practical about it. Let's say you could find enough, It's probably also, since it's more data, it's probably more work to analyze within subjects, since each one would probably take longer.
Which one would be more work to analyze?
Within subjects for an individual interview or individual experiment.
Right. Usually it's some task that you test people on or something. You put them in you zap their brain and put them in an fMRI machine. Are you on that paper?
The fMRI.
The brain zapping paper?
Yeah.
Did you just win an award?
Yeah.
Congratulations.
Yeah.
Nice, yeah.
That was within subjects.
So it's usually some, task that you have them complete, and then you observe their performance on the task or something, measure it. Not so much interviews. You may have interviews at the end. Or maybe you do a think aloud. That could be a thing. You could do a think aloud protocol, in which case you do have
That
you have
case
that.
would be more to analyze the need between subjects.
Well, yes, except in the between subjects, you would
I'm
need more
sorry.
people.
Within subjects.
It would be.
That's fine.
It would be, except in the between subjects, you would need more people. So, every person would give you less data individually,
Right.
but you need more people. So overall,
So you have to balance.
for you as the researcher, the amount of work is probably about the same, I would guess. How many, transcripts you have to look at or something. All right, you shorter transcripts for more people versus longer transcripts for fewer people. You had something?
Yeah, I think especially for the cases when when you want to measure have huge individual variations,
Yeah.
you will need much more participants to extract the effect out of noises. This is especially common in software engineering research. Like you ask participants to do some software engineering tasks, there are huge variations out there.
Yes.
And we usually do within subjects experiments because we cannot afford recruiting 100 or 200 participants to overcome that random noise effect.
Great. Yes. 100%. Right. So I think it's exactly what I was about to say, that individual differences can have huge impacts and obscurity effect. And you would prefer a within subjects design, which requires a smaller sample size, and can isolate these individual differences better. You can't always do within subject design. For example, if you're looking to test that there's no difference in the time required to implement a web server in Python between novice developers and experienced developers, there's no way to do this within subjects because you can't turn the novice developers into experienced developers between the two conditions. Makes sense? So, depending on your research question, sometimes you have no choice. Long.
Let me take a look. The really long studies that go from children to adults.
Yeah. Those would, yeah, so those would be closer to these examples we had earlier. Some of these, where there's a lot of observation of the same people over time. Maybe there's, interventions or treatments at different times, right? And sort of, it's also a longitudinal study in that way, yeah. Okay, very good. Here's a summary of this discussion, useful to remember. Okay. Right, so we talk about this idea of counterbalancing to offset these order effects. And a common design used here is called latent squares. Here's an example. Latent squares design, you okay, simplest case, a factor with two levels, say A and B. Then you divide participants into two groups. The first group, you give the administrative factors in one order, the second group in the other order. This is called latent squares because when you represent this as a matrix, you get all the same, A, B, you have all of the levels of the factor on every row, and you have all of the levels of the factor on every column. So I'll show you a bigger example here. Okay, here's a 5 level factor. The Latin square for this would be this. You have A, B, C, D, E, A, B, C, D, E, and so on. It's all the levels on every row, and it's all the levels on every column, and every one appears only once. So here, this is a lot. You need 5 groups to test the differences between these 5 levels of this factor. Only 5 groups. Right? And for every group, you sort of administer this in different order. But it's a way to get a lot more use out of few participants. And to counteract or counterbalance these order effects, these learning effects. And people either learning from the first task and applying that learning to the subsequent ones because you're changing this order, or getting tired towards the end and performing worse on the latter ones. Because again, you're changing this order. Okay. So I want to look at one super cool example. Yeah, okay. So here we're looking at 3 editing methods. We're going to call them A, B, and C. And we want to see how they differ in the time required for some editing tasks. Method A is using arrow keys, backspace, and typing. Method B is search and replace. Method C is point and double click with the mouse and then type in that place. It's a way to edit documents. So how do you go to where you need to edit and then type something in? They don't really matter what they are. Okay. You have 12 participants, and to counterbalance the learning effects, you divide them into 3 groups and you administer the tasks according to the Latin square design. Okay, so far? Yes? Every participant does 5 tasks, does the task 5 times with one editing method, and then again the second, then again the third. Okay, so they, I don't know, do 5 different things with each of these 3 methods. Right? That's the setup. So now here's the data you get back. 12 participants. And the 3 different conditions. Okay. And you divide the participants in 3 groups, and this is the order in which they completed the tasks. Right? And then you're measuring the time it took them to do that task. Okay, so that's the data you collect from the experiment. So now here's what's happening. If you compare, say, group 1 with group 3, group 1 did task this condition A first, and then the other group did condition A second. And you can see that the average task completion time is shorter for group 3 on task A than it is for group 1. You with me? So this could be because they've learned something just about typing. Right? Group 3 did another task first, and then they just got better at doing the task. And when you give them task A, they are on average slightly faster. Okay, because they've gotten better at the task period. Okay, so that's kind of cool. Here's another one. Starting with A versus ending with A. Now, these folks are slower when they do A. Possibly because of fatigue. it was too long by then, the experiment, and they got tired. Okay. Also note how the mean across all of these between the groups is the same, is indistinguishable. Which is good, what you'd expect. Okay, so it's not that, you know, the groups are really different substantially in their composition. Right, overall, across the entire experiment, the averages are indistinguishable. I think I have maybe, I don't have the error bars for this, but you can sort of see that they're about the same. Okay. Meanwhile, you can see how the third keyboard C here, or not keyboard, whatever, way of searching and editing is faster than the other two. And so that's pretty cool, right? It allows you to tease out this subtle effect while controlling for learning effects and fatigue effects. Pretty cool. Yeah.
This method seems pretty foolproof, but the order is still fixed. I mean, you snake it around. How do you know, like,
Yeah.
A is not just really a good example, and anything that follows A, you're gonna learn from really well.
Yeah. Good job. You're sort of getting at what I'm getting at here, I think. You can sort of tell that this lemon square design does not have all possible combinations here, right? It is a simplification, which is the point. Like you're trying to run the experiment more efficiently. Okay. So one thing to note is, for example, this, that right, conditions precede and follow other conditions an unequal number of times. For example, the A-B sequence occurs more times than the BA sequence. And so similarly, we can reason about other pairings. Okay, so you're right, Ian. Like, you know, if there's something here about, you know, going from A to B, right? That could bias your conclusions, your estimates here. I think it's the point you're making, right? Because you don't see the other order enough times. You don't see them all the same number of times. You don't see the BA sequence as often as you see the AB sequence, right? To cancel out those effects.
Can you give us random everything for each participant?
But then you need more of these. You need more participants. The trick is to do more with fewer participants. That's kind of the challenge, because in general, recruiting more participants is hard, or expensive, or both. So you're like, how can you get more confidence from fewer participants? How can you test more things with fewer participants is the challenge, just where this comes in. So, right, so let me show you another thing here. Comparing two scanning keyboards. So you see the, I don't know, control condition keyboard, which is just the typical. So this is for accessibility. You're sort of scanning through each letter until you find the one you're about to type, and then you click on that one and it gets entered, like one on TV or something, right? That's what you do. It's super annoying, right? And then you kind of, the cursor goes back to the beginning and you keep scanning linearly until you hit the next letter, and then you know, select that one and you enter it and so on. You keep doing this until you enter your text. That versus a version that comes with some completion here, like suggested words, right? So, you know, maybe you start typing and then it gives you suggestions for the most common words, starting with that prefix. And then you just jump to that and you select one of those. Okay. My GPS navigation system in my car does this with street names. So I have this like antiquated system where you can actually like type and you sort of have to like do this kind of scanning through letters, and it suggests the street names that kind of match that prefix, and you can select directly one of those before you have to type the whole thing up. Okay, so the experiment tests the difference between these two keyboards, and the control one I highlighted here in yellow. You can see that two groups of people, they were given tasks with the control one first, and then the auto completion one second, and then here we're switching the order. Okay. So if you compare their entry speeds, you can see that on average they're indistinguishable overall, right, across the two conditions. Okay. But if you compare across first versus second half, right, across columns, you see that first versus second would be this. Comparing this column to this column, okay, you see that people entry speed, so they're slower, right, than the other order. And then if you're comparing across groups, which is top row versus bottom row, you're seeing that maybe group 2 is slightly slower than group 1. So here's what this means. We have the first versus second trial versus the second half, and we have group 1 versus group 2. Group 1 is circles, group 2 is squares. And then you have the two different kinds of keyboards, the standard one and the one with whatever, WP, I don't know, the auto completion one. So this is all the same data I showed you in the bar charts a second ago. So here's what's happening. A couple of things to note. Both groups improved. Get this out of the way. Both groups improved at comparable rates between the first half and the second half of the experiment. Everybody learned and got better at the task the more they went through the experiment. Okay, so that would be comparing, first half to the second half. But it's harder to start with a more complex keyboard. The one with extra code completion, people were slower when they started with that than the default one, because it took some getting used to, right? They weren't fluent with it enough yet. It was newer to them. At the same time, eventually, the word completion one, the auto completion one, allowed people to type faster. Okay, than the standard one. So, this is an example showing this asymmetric skill transfer. It's also basically this example we had at the beginning. Gender as a moderator for the relationship between experience and salary. Here we have difficulty, relationship between order and speed is moderated by, relationship between keyboard and typing speed is moderated by order. Is that true? Is that true? Am I making stuff up? Relationship between keyboard and speed, or the default keyboard versus the fancy keyboard. The strength of this relationship is moderated by
Learning,
Entry speed.
by learning time.
by
The more time you spend using the keyboard will affect or that comes first regarding speed.
yeah, by difficulty of right, which is the same thing, I think, by difficulty of using the keyboard. Or learning time, how long it takes to become fluent with it. Okay. Good place to stop, I think. Hopefully you found this interesting. That's it. Happy spring break.